Let's talk about arc length and the area of a sector. They're similar in the way that their formulas look, but they are slightly different in what you are finding. So the formula for each one, as you can see, starts out with n over 360. N is the measure of your central angle that you're talking about, and then you multiply for arc length. You're finding like the pizza crust, like just the edge of that piece of the circle. So you multiply the fraction of the circle, so like whatever that measure of that angle is, over 360. So the measure over the total times the circumference, because you're just finding a little piece of the edge of the circle, which is circumference. But area of a sector is finding like the whole piece of the pizza. So you need the fraction of the circle you're talking about. So the measure of the central angle divided by the total of 360 times the area of the circle, because you're looking for a part of the whole area. So arc length is a piece of the circumference, and area of a sector is a piece of the whole circle. So their formulas look a lot alike. N is the central angle, and R is the radius. Let's look at some examples. So I divided it just like I did on the first board so you can keep your notes organized. These are 3 examples of finding arc length and 3 examples of finding area of a sector. So for arc length, we're going to use, you're always given a central angle, or you can figure it out, or you're given the radius, or you're given the diameter, and you have to divide by 2 so you can figure out the radius. So our formula is n over 360 n over 360 times 2 pi r, which is the circumference. So we are looking for the measure of arc AB. So I'm going to put 80 over 360 times 2 pi times the radius, which is 12. All right, so that reduces to be 2 over 9 times 24 pi. I've already done my work on my paper, so I can save some time, which calculates to be 48 pi over 9, which you could leave it that way. 48 pi over 9, or you could get a decimal, which is 16.76. So either way is fine. It just depends on what they ask for or what your answer choices look like. Let's look at number 2. For this one, we have an angle measure of 120 degrees. We're looking for the arc length divided by 360 times 2 pi r, and r in this case was 60. So we multiply that and we get 1/3 times 120 pi. And then we could reduce, because 3 divides into 120 40 times. So we end up with 40 pi, or, I've already got my calculation, is 125.66. Again, either one is fine. It's good to practice both, so in case you need one or the other, you know how to find it. And let's look at one more. These all clearly work very similar to one another. They're pretty straightforward. So you have 60 as your central angle divided by 360 times 2 pi r, and r in this case is 7.3. So it was a decimal, which is fine. That would be 1 over 6 times 14.6 pi, and then we would get 14.6 pi over 6, or we can get a decimal, which was 7.64. So you can see that these all simplify very similar. The only thing they might do differently is give you like a diameter, and you have to divide that to get the radius, or they could give you the angle that's on the opposite part of the circle, and you just have to subtract from 360 to get the one you need. Let's look at some examples of the area of a sector. So over here we're looking for a part of the whole area. So this one is just this little piece of the circle. So we would have area is 45 degrees over 360 degrees. Let me write that a little better. Times the area formula for a circle, which is pi r squared. So we have pi times 4 squared. And then 45 over 360 reduces to be 1 over 8. And then we have 16 pi. So we can reduce that to be 2 pi, or the decimal, which came out to be 6.28. Again, it's good to practice either one in case you need the one with pi or the decimal. Let's look at another one. This one gave us a central angle of 150. So we put that over 360 and multiply by the area. So area is pi r squared for any circle. So we have pi times the radius squared. So 8 squared is 64. And then we can reduce 150 over 360. That reduces to be 5 over 12. We still have 64 pi. And then that comes out to be 320 pi over 12. Or you can get a decimal, which would be, and that reduces to be 80 pi over 3, which is 83.76. So you'd want to reduce it. So I would say you definitely want to get it to 80 pi over 3 or 83.76. Now this last example gave us the measure of the angle that's on this side, but we really need the measure of the angle that's in that shaded area. So we would say 360 minus the 170 leaves us with 190. So if this is 190, that is the one we need for our formula. So we have 190 divided by 360 times pi r squared. So pi times 7 squared. So 190 over 360 will only reduce to 19 over 36. And then we have 49 pi. So this one comes out to be 931 pi over 36, or 81.25. Now you might think 81.25 looks like a nicer answer, but it really just depends on what they're asking you for and what you might see on an answer choice. But either one is correct, just one might be preferred over the other depending on what you're working on.